Well guys, let's prove that the derivative of e to the power x is e to the power x by expansion. So let's look at the expansion of e first. So the expansion of just e is 1 by 0 factorial plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial and so on. But here e is just a number, so that means the derivative of e will be just 0. So that's why let's raise e to some power x, e to the power x. So what will its expansion be? Well, obviously what I did just here is raise both of these sides to the power of x. But if you notice that if we did that, then this will just be a very large sum to the power of x, and there is no easy way to really expand that. But however, I have made a video on the expansion of e to the power x, and here it's quite easy. What you're going to do is, instead of writing these ones, you're going to write x to the power of these corresponding numbers right here without the factorial. So for the first one is x to the power 0 by 0 factorial. Then the second, x to the power 1 by 1 factorial. Then x to the power 2 by 2 factorial plus x to the power 3 by 3 factorial and so on. So if you want to write it in summation form, it will be this right here. As n goes from 0 to infinity, x to the power n by n factorial. Now we don't really need this because our main focus is right here. We want to find the derivative of e to the power x. So what we can just do is differentiate both sides with respect to dx. So on the left we'll have d dx e to the power x. So this is what we're trying to find. And let's see what happens if we differentiate the right hand side. So the first one, the first term you can see is x to the power 0 by 0 factorial. Well, x to the power 0 is just 1, and the derivative of 1 is just 0. And the next, we'll just have x by 1 factorial, and when you differentiate that, it's just differentiating x, which is just 1, plus the next term is x squared. Well, if you differentiate that, differentiating x squared, you'll get 2x by 2 factorial. And here x cubed is the same thing. The 3 goes down and this number reduces by 1. So you'll get 3x squared by 3 factorial. And again, for the next term, it will be x to the power 4 by 4 factorial. The 4 will come front and the power will reduce by 1. So which is cube by 4 factorial and so on. So right here, we can just remove this 0. So it is just 1 plus here. You have 2 by 2 factorial. And we can use the property of a factorial. So we know that n factorial is just n into n minus 1 into n minus 2 into n minus 3 and so on. So you can rewrite n factorial as n into n minus 1 factorial. And here you'll see that n factorial is n into n minus 1 factorial. So 2 factorial is just 2 into 2 minus 1, which is 1 factorial. And here, instead of doing the algebra and rewriting twice, let's just do something here. So we have n, just a number, n right here, by n factorial, which is this. So this will be equals to, here the n minus 1 factorial goes down like this. So what that means is here 2 by 2 factorial, this will give us 1 by 1 factorial, and this is just 1 by 1 factorial into x, so this is just this, plus here for 3 it will give us 1 by 2 factorial, and when you multiply it with x squared, it's just x squared by 2 factorial, and with the next one it will give us x cubed by 3 factorial and so on. So this series looks kind of familiar. Well, you can see that this is just that, right? Because x to the power 0 by 0 factorial is indeed just 1. And instead of 1, what you can write is x to the power 0 by 0 factorial. Because after all, it's just 1. It doesn't change anything. And right here, we know that this is just e to the power x. Right here. And finally, from here, we get that e to the power x, sorry, not just e to the power x, the derivative of e to the power x is just e to the power x itself. So this is the proof by expansion. If you guys learned something new, please like and subscribe. Thank you.